Hi folks, welcome back to Math with Captain Rod. Making this video here to take a look at our notes here for whatever section this is. So, review of functions. Let's start with this here. Domain, these are input values. Ooh, let's try to thin that line up a little. Can we thin that up a little more? Input values. Oh. Sorry about that. They're typically values of x. Okay, range are output values. When you're talking about algebraic functions, these are going to be the y values you get out of a function. If you have a function, then for every value of x, there's going to be exactly one value of y. If you have a value of x that has more than one value of y, that corresponds to it. It's not a function. The test for this is called the vertical line test. Let's get a little better color here. There we go. Yeah. All right. I'm using a system that's slightly different here. I'm using Word versus my normal program, but it'll take me a little while to get used to it. If you have a function that's 1-to-1, then for every value of y, there's going to be only one x value. The test for this is called the horizontal line test. And again, draw pictures to fit this criteria. Oh boy. Sorry about this, I'm not used to this system. Okay, so a function. Well, here's an example of a function that passes the vertical line test. A function that's 1-to-1. There's an example of a function that's 1-to-1. Both. Oh boy, well, I mean, that's this one. I guess I'll just draw this again. Right, that is a function that's 1-to-1. It's both. I'll have to come back and think about one that's 1-to-1 but not a function. I'll do that in a minute. Neither. Let's see. So something like this is neither. It's not a function. It doesn't pass the vertical line test. It also doesn't pass the horizontal line test. So let's see. 1-to-1 but not a function. So it passes the horizontal but not the vertical. Passes the horizontal but not the vertical. Give me a moment here to picture that. A sideways parabola. That would pass the horizontal. It's 1-to-1 because if I pick any value of y, there's one value of x, y, one value of x, but it doesn't pass the vertical. All right, let's move on here. Let's see. Using technology, determine the domain of the function and draw a quick sketch. Use algebra to show exclusions, try to find patterns. All right. Well, I'm not going to use technology. I'm going to do this by the method of the video that I talked about here. Hopefully you've seen my videos on finding domains. Assume the domain is all real numbers until you can show otherwise. This has no division by zeros and no radicals, so the domain of function number 1 is all real numbers. Done. Quick sketch. This is linear, slope -2, looks something like this. That's a real quick sketch, but good enough. All right, number 2, as far as find the domain. Start with all real numbers, and then try to eliminate based on division by zeros or radicals. There are neither of these, so the domain is in fact all real numbers. So there's our domain. Let's see, draw a quick sketch. This is a parabola, opens up, goes through 0, 1. That's pretty quick, but there's no axis here. So, all right, this animal. Start with assumption of all real numbers. Eliminate based on division by zeros or radicals. This one we're going to be able to eliminate something. x cannot be equal to 5, because if it were, we'd have a division by 0. So it's all real numbers except x cannot equal 5. There's our domain, all reals not equal to 5. Every real number in the universe except 5. Quick sketch. I don't have a graphing calculator on me, but I know this has a vertical asymptote at 5. Give me a moment here to think about what that thing looks like. I'm pretty sure. Give me a moment. Six, it's positive and negative. I'm pretty sure this thing looks like this. Boom. Boom. I'm going to go ahead and let the observer confirm that with a graphing calculator. And again, vertical asymptote at x equals 5. Okay, this animal right here. Find the domain. Assume all real numbers. Eliminate based on division by zeros or square root of negative numbers. Whatever 4 minus x is, it has to be positive or 0. It's got to be greater than or equal to 0. So 4 has to be greater than or equal to x. So there's our domain right there. X has to be, or 4 has to be greater than or equal to x, or another way to say that, x has to be less than or equal to 4. As far as a sketch of that thing, I believe that thing looks like this. Come out here to 4, I'm pretty sure it looks something like this. You can graph this on your graphing calculator and you'll get a better picture for it. All right, let's talk about that one. All right, start by, for the domain, assume all real numbers lest you can show a problem. Here we'll have a problem. Whatever x plus 5 is, it has to be greater than or equal to 0 as far as the radical is concerned. However, it's also in the bottom, so equals 0 is not allowed. So we'll just say strictly greater than 0. So x has to be greater than minus 5. So there's our domain. Let's see, range of that thing, or I'm sorry, quick sketch. I do not have a graphing calculator on me. I'm doing these by kind of, I don't want to put this, just sketching them kind of off the top of my head here. If we come over to negative 5, this thing's got a vertical asymptote at negative 5. I put 0 in, it goes through some value. This thing's looking something like this, I believe. Goes straight up like this. Again, anybody with a graphing utility, you can sketch it, get a better picture than that. Let's move on. All right, graph absolute value problems. Make tables to help. So we're going to graph a bunch of different functions here, and I'm going to go ahead and take the advice here of the person and make a table. And I'm just going to get kind of a quick look left to right here. Like if x is, let's say, negative 10, then y is going to be 10, because the absolute value negative 10 is 10. How about, let's see, what if x is negative 5? Run that through here, absolute value of it, y will now be 5. If x is 0, y will be 0. If x is 5, y will be 5. If x is 10, y will be 10. Now I'm just picking values here. You can, when you're doing this make a table thing, you can pick whatever values you want. What I did is I picked a value on the left, picked another one kind of about halfway, and then one at 0, and one at 5, and one at 10. I just kind of looked at the graph I was given and started on the left and went left to right here. Now we'll start plotting these. Negative 10, 10. Negative 5, 5. 0, 0. 5, 5. 10, 10. And I wish I had a straight edge for this. These do in fact run in a line. Whoops, And there's a graph. There's our first function. That is a graph of y equals absolute value of x. All right, let's talk about this animal now. I think what I'll do here is change colors for this. We'll do this one in, I don't know, red. Make our table. I think what I'll do to conserve room here is make my table up here. X, Y. And again, this is for this function right here in red. I'm going to go ahead and choose the same values here. So that first negative 10, and then absolute value of that plus 7 is 17. That one's off the graph, and that's okay. This point is way up here somewhere. Let's try the negative 5. Negative 5 absolute valued plus 7 is 12. That's one I can actually get on there. That one's here and a little higher. Go ahead and put that in there. It's about that point right there, give or take. Okay, let's see. Put in x equals 0. Let's see what comes out. Put a 0 here, plus 7. We get a 7 out. Let's put 5 into this thing. 5 absolute valued gives us a 12. And again, let's put 10 into this thing. 10 absolute value plus 7 is 17. All right, let's start plotting some of these points and see what we got. This one we already said is off the screen. We already got that one. Let's see, 0, 7, 5, 12. Again, that's almost off the screen there. And this one's way off, but hopefully you can see what happened. The plus 7 here took every one of these points and raised it up 7 units. So we'll go ahead and sketch this. This just goes on forever in that direction. Same thing in that direction. So again, an important fact here is, what did the plus 7 do? It took this graph and raised it up 7 units. Had this been a minus 7, it would have taken the same graph and brought it down here, made it, would have dropped it down 7 units. Take a look at this one. And I'm going to use a different color here. Let's use green. So let's make a table. X, Y. And I'm just going to, again, pick some values here. Let's start with that same negative 10. Negative 10 plus 4 is 6. Absolute valued is 6. Negative 5 plus 4 is negative 1. Absolute valued is 1. I'm going to run one more here. Let's put negative 4 in, because you'll notice that negative 4 plus 4 is 0. The absolute valued is 0. That's an interesting point. Let's see, 5 plus 4 is 9. Absolute value is 9. Let's see, 10, we're going to get 14. That's going to be off the graph. Let's do 7, I guess. 7 plus 4 is 11. Absolute valued is 11. All right, let's go ahead and start putting these points on here. Okay, negative 6, 10. Or, I'm sorry, negative 10, 6. Negative 10, 6. Negative 5, 1. Negative 4, 0. 5, 9. Ooh, that's off my screen. 5, 9. And, maybe one more in here wouldn't hurt too. Let's do this one. Let's put x equals 0 in too. Okay, 0 plus 4 is 4. Absolute value is still 4. So 0, 4 is also on there. Whoops, 0, 1, 2, 3, 4 there. Go back and sketch. Boom. Boom. All right. So when it said something about patterns earlier. Here's the original graph, y equals root x. So this one. The plus 7 here moved that up 7 units, right? That's our red graph here. Had that been a minus 7, that would have dropped it down 7 units. This plus 4, now you'll notice that it's kind of attached to the x, if you will. Notice the 4 gets applied before the absolute value, meaning that if I put in a value for x here, the 4 gets applied, and then the absolute value is applied. And that has a different effect. Notice that that took this point and moved it to the left 4 units. It took this point, moved it to the left 4 units. Took this point, moved it to the left 4 units. So the pattern here is that that plus 4 had the effect of moving the graph f of x equals absolute value of x to the left by 4 units. And again, we'll talk more about that later on here in the notes. I think what I'll do is stop this right here because the video is at 15 minutes and I don't like them to get longer than 10 or 12. So I hope that this helps with your notes. Let me go back and give you one more look at that graph. These are what your graphs should look like. Have a great day.